Hey everyone, I'm Dan Hienzsch, the resident engineer here at the Supplyframe DesignLab, and we've got a special treat today. The Arduino Foundation sent us their Arduino Engineering Kit, which is in this box here. This is supposed to be a kit designed to help educators teaching more engineering topics for their student body. More than just sort of blinking an LED and stuff like that. This was designed in collaboration with a company called MathWorks that makes the software package MATLAB. To allow you to do some really deep engineering challenges like computer vision, physics simulations, and things like that. My understanding is that part of this kit are actually 3 projects. One is a computer vision project where you can have a robot that moves around trying to either identify its location or identify objects that it wants to move to and pick up. There's another kit in there, or another project in there, where you can build a robot that analyzes what's drawn on a whiteboard and then duplicates that using a couple of dry erase markers. And then something I'm particularly excited about, there is a self-balancing motorcycle project in here. And that's all done using the Arduino hardware, using the Arduino development environment, and then the MathWorks software packages as well. So let's open this up and see what we got inside. This was in fact sent to us by the Arduino SRL in Torino, Italy. So this is authentic, straight from the source. So this is box right here. So this is the Arduino Engineering Kit. Bring the power of the Arduino MKR 1000 board to the engineering classroom with MATLAB and Simulink. This looks like, you know, it's always nice when they send you a toolbox that can be repurposed after the fact as, you know, something that is useful going forward rather than just something that you open up, take all your parts out, and then wind up having to toss. So, you know, props to them for that. So let's get this open right here. And so we got quite a lot of stuff in here. So we've got a bag full of plastic parts. These are probably this is parts for the drawing robot right here. Let's open this up and have a look. This is nice. These are all, looks like these are 1/8 inch acrylic. That's, I think, 2 millimeter acrylic. Looks like it was laser cut and then possibly drilled after the fact. So that's nice. This is solid, sturdy stuff here. It'll be easy to work with. It won't break down. It won't snap or fracture unless you really sort of, you know, go to town on it. Got drawing robot kit, and then there we go. We got the self-balancing motorcycle parts right here. Dig deeper into that in a little bit. And then mobile rover parts. And then what else we got here? We have, I don't know if these look like maybe wheels or rubber to go onto the plastic wheels that we got here. Give it a little bit of friction, a little bit of tread. Little pulley of fishing line. Red, green, blue dot. I don't know if this is going to be used as a target for machine vision to locate on, or maybe, you know, something that allows you to do precise alignment, maybe with scanning with a phone from on top or something like that. Battery charger maybe here. Yeah, compact charger. So somewhere in here I'm expecting to find probably some lithium-ion batteries. It's got these, I think these are JST connectors on the bottom here. Looks like it's capable of charging 3 cells at a time, so that's nice. Hopefully they've got the power cord in here as well. This is the Arduino Maker IMU shield, so that is inertial measurement unit. So this will be doing accelerometer data, trying to detect motion, more acceleration. Like if this thing is just sitting still, it's not going to tell you where it is. It only really gives you useful data as it moves because it's an accelerometer. So it measures the acceleration of an object, and depending on the accelerometer that they have on there, it'll either be in anywhere from 1 to 6 degrees of freedom. So 1, 2, 3, 4, 5, and 6 degrees of freedom. We have the motor shield, so makes sense. We've got a whole bunch of things that are going to be moving around, so we need to be able to control the motors. This will have probably some kind of maybe an H-bridge on here, or maybe if there's stepper motors involved with this somehow, a stepper motor driver. And then the MKR 1000, maybe it's the Maker 1000. This will most likely be the actual microcontroller unit, and this comes with headers included as well. So what we got here? A couple of nice stickers. And yeah, so this is the this will be the brains of the operation right here. So we've got, I'm not entirely familiar with this particular model of the Arduino, but sort of typical things that you would expect to see. I've got looks like 6 analog pins, 5 digital pins on this side. 4 of them have pulse width modulation. The other side, 5 volts, 5 volt output. We've got a voltage in, we've got a VCC, ground, reset pin, and then digital 6 through 14 with SPI and I2C and the UART pins on this side. So this is how we'll be doing our communication with what other, the various sensors that we've got going on here, and how we'll get the output to the motor shield to make stuff move around. Let's see what we got in the tray over here. So this is interesting. This is where a lot of the magic and the fun happens right here. So out here we've got structure, we've got output, and we have brains. What we have here looks like the actual motion control stuff. So we've got, like I said, a couple of dry erase markers that work with, I believe, the drawing robot. Power cords here, USB cable probably for charge or for communicating with the microcontroller, programming it. Power cable for the battery charger. It's got the European style connector on it, but they were nice enough to provide us with a universal adapter. So hopefully with this, unlock it and boom, out pops a little Edison connector right there. Perfect. Cool. So I don't have to go, running around trying to find the right connector for this. That's cool. Well thought through. This is nice. These are the these will be the things that we use to charge the batteries with the battery connector right here. Here we go. This will be the battery pack right here. Lithium polymer battery. Looks like they've got 3 cells, probably all connected in. Well, honestly, I don't know if they're connected in series or not. We've got two cables coming out of the side here. So this will be a little bit interesting to see how this is all configured. It says it's 800 milliamp hours, so you should be able to get a pretty interesting amount of capability out of this. It also says, kind of curiously, that it's 11.1 volt. So, so somehow, some way, these batteries are interconnected inside. And I forget what the usual lithium polymer voltage level is, but it's in the 3 to 4 volt range. So if we've got 3 cells in here and possibly more, and it's outputting 11.1 volts, then we've got some batteries connected in series inside. So that'll be interesting to see how we use that. We've got rubber bands, always useful. And a servo motor, a little mini servo motor. Not guessing that this is sort of the highest quality, probably plastic gearing inside. I don't know whether this is capable of doing full 360-degree motion or not. It's possible. I've got some nice, cute little neodymium magnets here. These are nice and strong. Probably useful for sort of holding different parts together for ease of assembly and disassembly. Make sure that we get those connected to something so we don't lose those. Timing belt, which makes sense because we've got our timing wheels here. And this is how we're going to be able to not just transfer rotary motion from a motor, say, to a wheel, but be able to do so precisely because these teeth on the wheel here aren't just random. These are specifically machined into the aluminum here so that you can get that belt to sit very precisely on there. And then provided you've got the right tension between the two wheels, and get that like that, that means that you get a very specific rotation on one side gets transferred to the other side. So if I rotate, say, you know, the wheel on this side by a quarter turn, it's going to turn the other side by a quarter turn as well. Oh, this is kind of interesting. This is a ball bearing that's trapped in a little plastic enclosure right here. So this is able to really easily float and roll across a hard surface. So, you know, I haven't looked at the instructions for any of these projects yet, but you know, since this is sort of omnidirectional, what you can do is you could have your two wheels to sit on either side of your robot like this, and then you can just take this sort of omnidirectional and put it down here in front, and you don't need a third wheel. All you need is just this little ball bearing that's free to move in any direction whatsoever. And then by moving both of these wheels forward in the same direction, it moves forward. By moving them in the opposite direction, it moves backward. And then by counter-rotating them, you get it to turn on a dime, right? So, so these would get mounted on the outside of the robot. These provide forward, back, and rotation. And then this provides a point at at either the nose or the tail of the robot to just provide some additional structural support at the different positions. This is a cute little solution. I like this. This is super easy. This would be, you know, for if you've got a 3D printer at home, modeling up something like this isn't really particularly challenging at all. And it's, you know, you don't have to get these dimensions super precise. You just need to get sort of a little bit of an angle like that, and then just mash that ball bearing in there, and provided it's got just enough ability to rotate inside, you know, this provides you with a quick way to provide support and ease of motion for a robot without having to try to print out something, you know, this giant wheel like this. What else have we got in here? We've got a little DC motor. Doesn't tell me really much about a TT motor. And then it's got 2018-0330. I'm guessing that's the date of manufacture on it. This is a DC motor. It's not an alternating current motor. Basically, I could just grab a 9-volt battery and power it up right now and draw a lot of current, make a lot of noise. Usually you control these with like an H-bridge transistor array. Ideally for something like this that throws off a lot of electromagnetic noise, because it's got a bunch of electromagnets inside of it, you'd want to isolate this from, like, you know, your IMU shield. You'd want to isolate it electronically using an opto-isolator or something like that, just so that all the noise that's generated from this doesn't get spread around all of your circuit. What else we got in here? Little Hall effect sensor. Wow. So with this Hall effect sensor, the sensor itself is actually just this tiny little guy right here. That's a really tiny little sensor with all the supporting electronics around it on the circuit board, and then just this quick little connector right here to get it set up to communicate with whatever it's going to communicate with. See what else we got. We've got a ultrasonic sensor right here. So these make an ultrasonic tone that's not audible to humans. And what happens is that tone gets broadcast out, and then it detects the reflection of that tone to determine distance from something. We've used this a bunch of times in the lab here. for various things, but it's really for distance measuring. And since we've got something here that's trying to detect where something is, so it can try to pick it up, I imagine this is probably going to go with the mobile rover right here. Got some gear motors here. Possibly, yeah, I think these are actually stepper motors based on the amount of wires that are coming off of these things. So this is a stepper motor, and the stepper motor allows you with the appropriate circuitry, like on the motor shield here, to move the shaft of the motor at very, very, very specific increments or degrees of rotation. So if you want to say that, you know, I want to take this shaft and I want to move this shaft specifically 22.3 degrees, that's what the stepper is capable of doing. Now, it's got this very, very intricate gear train in here. So I imagine what's going on is that this is, well, it's either sacrificing rotational speed for torque, or it's sacrificing torque for rotational speed. A lot of interesting things that we're going to be able to do with this set. So it looks like we've got two of these gear motors, or these geared stepper motors here. A couple of little plastic mounts, and then screws, more screws, lots of screws. Screws, some more bushings, spacers, some kind of drive shaft most likely. Keyed shaft right here. So with a keyed shaft, you don't need to have like set screws like you have on this pulley right here, provided that you have a keyway on the axle or on the hub that you're pressing it into. That provides that positive identification for rotation right there. If this was, you know, a round shaft and a round hole, then you need to have the set screw to provide a little bit of friction on there so that it just doesn't rotate right around inside the middle of the hub. So more bushings here, more nuts, more screws, bunch of little set screws, it's kind of expected. So these little guys inside here are the set screws that'll go inside like the tooth timing wheel right here. Those will hold those nice and snug in place on the shaft. So like I was saying, you can see here on the hub, this is keyed right here. So that works really well with this shaft to sort of provide a positive indication for the drive shaft to the hub so that it rotates without slipping inside the hub, whereas these timing wheels fit onto the shaft, and if I hold the shaft tight, that wheel still spins on there. So I need to provide some method for actually holding that tightly in place. Set screw goes right down in there, spin it down, get it snug, and it'll hold it in place on that hub. I have no idea what this is right here. This is kind of cool. It looks like this is a little collet that might be inside here. Something would get set inside there, and then as this expands, it squeezes down on that collet and tightens it up on something. So maybe there's there's some kind of shaft or a screw or something that slips inside here, and then maybe, yeah, I mean this sort of half pulley here has got little teeth on it for providing, you know, extra grip force and some extra friction. Boy, I'm just really speculating as to what this is. This is fascinating. I've got no idea what this is for. It's got this little eye through the top here. So something gets threaded through the top up there, and then, you know, like I said, something gets seated in that collet, and then that gets pulled up tight against it. But man, it'll be interesting to find out what this gets used for. That's pretty cool. And then finally, we've got some little USB camera here. PC camera, megapixel, USB 2, 3.0 megapixel USB camera. No idea what the quality of this thing is. I mean, you know, just based on how it feels and how much it weighs, I'm not going to guess that this is the best USB camera available. But you know, for machine vision, you don't need, you know, the greatest of detail. You're not taking portraiture with that thing. What you need to be able to do is resolve one thing from some other thing, and you know, 3 megapixels, that should be enough to do that. Sort of interpret shape and color from each other. So obviously this is probably going to go with the mobile rover and the drawing robot, and I don't know, maybe it's got something to do with the self-balancing motorcycle as well. So that's what we got in this kit. Yeah, so apparently I need to go to create.arduino.cc/edu/reg, follow the instructions, and then submit a code. And probably this licensing code right here is going to get me access to MATLAB and Simulink. Apparently, with the purchase of the engineering kit, you get a 1-year license to MATLAB, which is pretty cool. And then it's got a list of the contents, control systems, inertial sensing, image processing, robotics to your engineering classroom. So that's it for this unboxing. We went through the Arduino Engineering Kit, had a look at the contents of what's inside. In part 2, we'll come back, do a little bit of research, figure out where the instruction manuals are for this stuff. And as much as I'm interested in the mobile rover and the drawing robot, I think what I'm going to be trying to do as a motorcycle enthusiast myself is trying to build the self-balancing motorcycle here, which is going to involve you know, a lot of the stuff that we see in front of us here, from the motor shield, the inertial measurement unit, and the Maker 1000 board, and any variety of the different sensors and actuators that we have in front of us. So come back for part 2 and we start putting this stuff together. Thanks a lot.